Okay, we're live streaming now.
Excellent, thank you. So welcome to ESMARConf 2023 and this workshop on an introduction to R Shiny. This workshop is being live streamed to YouTube and has also got a group of participants taking part live with us on Zoom. So a very warm welcome to you all. If you have any questions for our presenters, you can ask them by the ES Hackathon Twitter account by commenting on the tweet about this workshop. You can also post on our dedicated Slack channel that was sent if you registered for the conference. You can post on the YouTube live stream, and also if you're here on Zoom, you can ask the question in the Q&A facility. We do endeavour to answer all questions as soon as possible. We'd like to take your time to draw your attention to our code of conduct, which is available on the ESMARConf website at www.esmaconf.org. Our workshop presenter is Caitlyn Hare from the University of Edinburgh and the Camarades Research Group. So over to you.
Thanks. Thanks very much, Chris. Hopefully you can all see my screen. I'm just going to move this along slightly and we can get started. Here we go. So today I'm really happy to be here introducing R Shiny. This is very much an introductory workshop, but hopefully everyone here has at least some experience with R, because it's going to make it a lot easier for you to understand what I'm talking about. So just a very brief introduction to where I'm coming from. So as Chris said, I'm a researcher at the University of Edinburgh, and I'm a postdoc within the Camarades Research Group, and we work on essentially large systematic reviews and meta-analyses of experiments and animal models of mainly neurological diseases. And I'm interested particularly in neurodegenerative disease, so that's kind of where I do my systematic reviews. I also work on developing automated tools for evidence synthesis and developing pipelines to try and put all these tools together. And through my work in recent years, I've developed quite a lot of Shiny apps because I think they're a really good way of communicating. Well, I've actually got some use cases of where I've used Shiny apps in a few slides time, so you'll see what I've used them for. But I find them just a really useful way to sort of communicate with the wider research community without them having to learn R themselves. So this is just a few links here if you want to get in touch with me on Twitter. Have a look at my GitHub page or the Camarades GitHub page as well. Hopefully in the chat soon, there's going to be a link distributed, which is a link to one of the GitHub repositories that we're going to use today for the workshop. So while I'm talking in this first half of the presentation, if you could have a look at that and try to download the files, that's going to be really helpful for later on if you want to follow along with what I'm talking about. So the workshop today, this is how it's going to work essentially. I'm going to start off with some slides about what Shiny is, why you would want to use it. Then I'm going to go into a bit more detail on what the fundamental aspects of a Shiny app are, so inputs, outputs, all of that sort of stuff, so that you understand the very basics of what a web application is and what a Shiny app is. Then we're going to create our very first Shiny app in R, and you can follow along with that as well. We're just going to be modifying the sort of boilerplate Shiny app that you get when you try to make one for the first time. We're going to go through some example Shiny apps which I've made, and they're available on that GitHub repository. So we're going to walk through how I created them and different use cases for those apps. I'm going to set you all a challenge as well, building on from this workshop to create your very own app based on what you've learned on the workshop. Probably we won't have time for you to actually start working on that today, so I sort of see that as an after workshop activity, but let's see how much time we have. And finally, I'll have some more slides about the next steps you can take with Shiny and some considerations if you actually want to start making Shiny apps in the real world for your own research purposes. So let's start off at the very beginning. What is R Shiny? So it's an R package that allows users to create an interactive web application using R code. What it's actually doing in the background is it's calling things like HTML, JavaScript, and CSS, because that's actually what's building the website. But you don't need to learn those languages, which is the benefit of using Shiny. You only need to understand R and how to write Shiny apps in R. So that's a benefit, and especially for someone like me, I don't come from a programming background at all, so the idea of creating a website always felt impossible, or like something that someone else would do, and I'd never be able to do that. So it's really great to use something like R Shiny and make that possible. So why would you actually want to do this? I just wanted to give 3 quick examples from my own research in places that I've used this. So first of all, quite often if you're performing something like a systematic review, meta-analyses, in our group quite often there can be hundreds of studies and all different animal models and all different treatments, and there's actually so much data, it's really hard to even put it all in a publication. And you can share the data on Open Science Framework or wherever you share your data, but it's nice to be able to present it in a more visual way, so that if someone was interested in exploring your data set further, they could actually visually interact with it, filter to get the data they're interested in, and look at some nice plots. So that was actually the first Shiny app I made, was an app to visualize a systematic review data set and allow people to interrogate the data a little bit more. One of the next Shiny apps I made was one to make an evidence synthesis tool more accessible. So I created a deduplication tool in R, and then when I wanted to share it with some colleagues who didn't know R, it just became very difficult and confusing. So to sort of save myself future work, I created a Shiny app that allowed people to run this tool without having to know R themselves. So that's another example of where a Shiny app can be useful. Thirdly, just to give maybe a slightly more advanced example, we're now using Shiny apps in our group as resources. So rather than just at the end of a systematic review when you're displaying your data, now we have Shiny apps linked to SQL databases that query huge amounts of data and allow us, they're actually like a starting point for our systematic reviews now. So it's kind of went full circle, and now we're actually using these as a resource to create more research in the future. This app, Alzheimer's Disease Souls, it's essentially a systematic online living evidence summary of the literature in Alzheimer's disease animal models. So it's got lots of visualizations. It's a lot more complicated as an app, and it's doing lots of more complicated things. So it's just to kind of show you an idea of the scale of what you can do with a Shiny app. So what is a web application, really? I was kind of, when I was putting together this presentation, I was trying to think about this, because every website that you use is essentially a web application. And what they're all basically doing is that they have a user interface or front end, and that's the part that you're actually interacting with. So whether it's Facebook or whatever website, the part that you're clicking on is the user interface, and that's what you're interacting with. And essentially what happens is you click something and then you're shown something. So you click a button and something happens or something pops up. The other component is a server or backend, and that's the actual sort of computer part in the background that's actually carrying out the computations or tasks based on those user inputs. So those are the sort of fundamental building blocks of what a web app is. And these are also the 2 fundamental building blocks of a Shiny app. So this is some Shiny app code here. When you create your very first Shiny app, it actually sort of comes in this sort of format so that you have something to start with. And as you can see, within this code, the very first thing is you need to load the Shiny package, and then it gives you these sort of two chunks of code: UI, user interface, and server. So within the user interface, you start off with quite often what's called a fluid page. So this is like a function that basically is generating a page. And within that, you can put lots of arguments. And then again, in the server is actually a function. So you can see input, output session here as arguments. And within that function, you add all of the code relating to the computations. So to illustrate this, just to indicate what things will be in this UI chunk of code, you've got things relating to the layout of the Shiny app, the theme, so what the website's going to look like, the user inputs, so the ways in which the user can actually interact with the web application, and the outputs, things like plots or tables or whatever is going to be displayed on the app. And then in the server, that's where all your computational, your code to generate values or plot, or in the back end, what's actually happening. And you'll understand more about that as we go through, hopefully. So I wanted to just dive into slightly more detail. What do I mean by layout? So here is a very classic Shiny app layout where you have what's called a sidebar panel and then a main panel. So essentially you can see here fluid page is kind of generating the page, and then you have some other functions within that to generate the title, to generate this layout, and to generate this panel and this main panel. There's alternative layouts, so you can have things like where instead of having the side panel, you can generate a row on a web page and then have two columns of certain sizes. You can generate another row and have some more columns. So this is just a representation of this example web application and what the actual layout looks like. And you can get more complicated as well. So you can build Shiny apps that have multiple pages and Shiny apps that have multiple tabs within. So you can see this one has a sidebar layout again, but it's got sort of multiple tabs within the main panel showing the plots. So it can get fairly complicated. In terms of theme, I just wanted to highlight, it depends how much you care about this stuff. For me, like how a Shiny app looks is it's really fun to play around with that, but not everyone cares about that. But you can do lots of different things to make your Shiny app look nice, and here's just an example of some different themes that you can use. So Shiny app inputs, what do I mean by that? I mean ways that the user can interact. So there's all sorts of different inputs available. There's things like file inputs where you can upload a file to a Shiny app. There's text inputs. There's checkboxes and radio buttons. There's drop-down options as well. There's action buttons. So when you click it, it triggers something to happen. There's also sliders. So if you want to maybe slide between different years, if you want a range of years, for example, or dates or something like that, you can use a slider as well. And this is just a small number of inputs. There's many more, but it's just to give you an idea of the ways in which you can interact with a Shiny app. In the code, each input must have a name. So this is really important. They all have an identifier. So this is just showing you sort of example code for this radio buttons input. So you can see it's the function is called radio buttons. The very first part of this is radio, which is not a very descriptive name, but that is essentially the input identifier for this. Oh, didn't mean to click there. For this button, we've given it a label here, so we've called it radio buttons, which is how this label comes about. We've put in some choices, so you can see there's a list here of different choices: choice 1, choice 2, choice 3, and we've made it so that by default the selected value is 1, which is choice number 1. So then later, and we'll talk more about this later on, so don't worry if it makes absolutely zero sense right now. We can refer back to this input using input $radio, because that's the name that's the name that we've given this input. So as you can see, because the default value is 1 here, if we were to look at this value in the R code, it would be equal to 1. And then we could use that for computations later on. So that's kind of how it's linking together. And every time a user clicks this button, so if they click choice 2, then that input value would change to 2, and then that's the value that would be used in our computations. Briefly, I just wanted to touch on different outputs. So there's lots of different outputs and really nice visualizations that you can make in Shiny apps. So you can do all sorts of different plots. You can have images as well. You can have really nice looking maps, and you can have tables. Again, this is just a small selection. Similar to inputs, each output must also have a name or an output, identifier. So here, again, this is from the user interface that we talked about in the last few slides about radio buttons. So this is the input here. If we were to create an output, oh, I thought that was in this slide, but oh yeah, okay. So as you can see, we've got radio buttons here, and then the HR is just like, it's essentially just generating this this line. Some of this stuff will be easier to you if you have done a bit of R Markdown. So some of this stuff about like H3, for example, maybe I should have said that is a sort of level of header, and it's just about the size of the text that appears. And this line, for example, things like this are kind of more familiar to you if you're used to R Markdown. But that's what that is. And then we have underneath here, we have what's called verbatim text output, which is just something that you'll come to know. It's just one form of text output, and it's actually just it's outputting a value. And let's see how that actually works in terms of the connection between the input and the output here. In the server chunk of code here, you can see we have this output $value. Now that's relating to this verbatim text output value. You'll see that's the same name that's been given. And we're using this render print function, which essentially is just printing out our input. So you can see if this input radio is referring back to our radio buttons input, which we said as a default it's set at 1. So we know the value of that input radio is 1, and this is basically just printing out 1. So this is kind of the most simple example of an input, and then it reacts, it changes that input value, and it leads to an output. So that's kind of a very basic understanding of how this concept of reactivity works in Shiny, because essentially every time you change an input value, the output will react to that and change based on that that input value. So, oh, computations, yeah. So that's just the computations happening in the server. So all of this makes much more sense when you actually see it happening in an app. So what I would say is the best thing to do if you're following along with this workshop. Open RStudio now if you haven't already, because we're going to create our very first Shiny app and just play around with the sort of boilerplate template that RStudio gives you. So if I move this along a little bit, hopefully this will expand. Okay. So hopefully you can see this, and I'm going to go to File, New File, and then where are we? Shiny Web App. So here. And this will create a Shiny web application to start with. So you can give it a name, it doesn't really matter. So it used to be in the past, quite often the user interface and the server were actually in different, they would actually be in different R scripts, but more commonly now people tend to have them all in one single R script. So that's what we're going to do today, but that's just what this option is of the single versus multiple file. So we're going to stick with the single file and create this. Okay, so this is our very first Shiny application, and as I talked about earlier, it's got this user interface bit of code and it's got this server part as well. And just straight away we can actually run the app because it should work already. So I'm going to click this to run the Shiny application and it will open here. So I can't actually even remember what this is. I feel like it's, yeah, earthquake or waiting time to next eruption. Can't remember, but essentially you can change the number of bins in the histogram. So you can move this slider input and you get a change in this output, which is the histogram. So that's what's happening here. So you can play around with that. So I'm going to close that again and have a look at the code in a little bit more detail. Oh, I've just seen from the chat, it's, yeah, guys are in Yellowstone. Yeah, so that's what it is. I feel like I knew it was something important, but I just couldn't remember. So if we have a look at the app code here, you can see we've generated a fluid page. That's this very first part of code in the user interface. We've got a title. I'm going to add Yellowstone here because that will help me remember. And if we run that again, you will see that has now updated the title. So that's a very simple thing you can also do in your app to just add a bit more detail. So I'm going to stop. So that's the title panel. That's fairly self-explanatory. Now, this is the sidebar layout that I was talking about. So, and again, if all of this is new to you, I would just encourage you to use the question mark and any of the functions to just get a bit more detail on what they actually mean and what the arguments should be, because it's when I first started learning Shiny, it did feel almost like a different language actually from R, because there's so many different functions and it does take a while to get your head around. So keep looking at the individual functions to understand what's happening. But essentially, we're creating a sidebar layout with a sidebar panel and a main panel here. And within that sidebar panel, we have the slider. And within the main panel, we have a plot output. So the slider input I mentioned earlier, this is just a form of user input. We've given it an identifier. So let me have a look at this. So you can see the very first argument is input ID. So I'm actually going to write this here just so it's super clear. So the input ID is bins, because that's the name that R has given it. Then we've got the label here. Label, number of bins. For slider input, you've got a minimum value and a maximum value. And the final one here is the value that it starts at. So the default value that's going to be shown on your app. We also have this plot output, and we'll talk a bit more about what's happening in the server. So just generally with these sorts of inputs and outputs, there is a standard sort of naming convention that tends to be for outputs, it will be in the user interface, it will be like text output, plot output, HTML output, image output. This sort of thing is usually how it's shown in the user interface, and usually that's the function that you would use, whereas in the server, it's usually render whatever that output is going to be. So here you can see we've got plot output, and then we have render plot in the server, and that's going to be the code that generates that plot. So within here you can see it's generating bins, and the bins are based on this input bins, which is our, if we go up here, that is our input from the slider input here. So that's how it's interacting with that value. And actually, if you want to look at this in more detail, just so it's crystal clear, what I quite often do is add a browser here. So you may have used this in your R coding in general. It's very similar to a code break, one of these here, but it basically does the same thing, where it will break the code and take you into this part of the function so that you can play around with the values. So in fact, actually, I think I'll need to put it within here so that it actually stops in the right place. So if I run that again, you'll see it's allowed me to go into here and actually look at what's being generated. So you can see if I just put input bins into the console, you'll see it's coming out as 30 because that is what we have here. If I change this to 14, if I click continue just to make sure that's reevaluated, you will see if I put input bins here, it's now 14. So that's where it's getting that value. That's where that's coming from. So I'll stop that and get rid of this. So one sort of simple thing I thought we could add into this app is, as I said, I like to make apps look nice, and this is very ugly. So let's add an extra input option to change the color of the graph, because that's going to be something we can add quite easily. So how we're going to do that is if we go to within this sidebar panel here. Traditionally within these apps as well, in the sidebar is kind of where you enter all of the inputs, and then the main panel tends to be where you display the output. So let's add it to that sidebar panel. Something I also didn't mention within the user interface is, because it's essentially using fluid page as the function, and all of these bits are actually arguments within the user interface. So you actually need commas in between basically everything you do in this UI section, which is confusing initially. So after we've finished with this slider input, we'll need to have a comma. And it's kind of up to you what kind of input you want to put in. I think I'll probably put in radio buttons, because that allows you to select between different options. So let's do let's see, radio buttons. And if we have a look at what's within this radio buttons function, you can see input ID is the first thing. So let's give it an input ID. Color radio, I'm going to say a little bit more descriptive than bins. Label, I'm going to say pick a color. Pick a color. Choices. So you can pick any colors you want. I think I'll go for green. Oh, green, red. Oh, can't type. Red, yellow, blue. So there are some choices, and that's really all we have to do. Well, actually, the final thing we have to do is set a default value. So let's say selected, which is going to be the default value, equals green. Let's start off with green. Okay, so you'll see what's happened here already. If we run the app again, you'll see I've created these radio buttons, but they don't actually do anything yet. So let's make them do something. And to do that, we would go down to this this plot here, this plot, and within the histogram function, you can see that the color is already dark gray. So we don't want it to be that. So we want to get rid of this and instead have input. And what did we call our input? Color radio. Here we go. So we've now changed this to our input value. And if we run this again, hopefully, yes. So now this is changing based on the colors that we select. So that's just a very basic understanding of how reactivity works. The input changes, it's mentioned in this this part of the server where we're rendering the plot. Every time this changes, this whole bit of code basically gets run again, and it recalculates, and then the plot is regenerated. So that's what's happening here. So now I want to go a little bit more detailed and to describe essentially the progression of an app for a specific reason. So this is going to be a use case, and if you, I don't know if it's in the chat again, we should, could we post that in the chat? The let me see, I don't think it's there yet, but essentially I have a GitHub repository which I'd really like you to download the R code from. It depends if you feel comfortable cloning the repository. I don't know how you feel about GitHub. You can also go on and just download the files individually. So it's available here. I will also send it in case that helps. Let me see.
Just put it in the chat.
Yes, I will do that.
And it's on Twitter and Slack as well.
Perfect.
I don't know if it's sent on YouTube, because YouTube seems to not like links, but it's everywhere else.
Perfect. Yeah, I just couldn't see the chat there. That's perfect. Great. So hopefully you can download that. Again, if you don't feel great about GitHub, you can copy this, or you can download the individual files. You don't need to clone it. Depends how you feel about GitHub. So while you do that, let me just talk briefly about this again. Okay, so this is going to be a data set about dogs. Now, you may or may not like dogs, but the reality is, I think my reasoning behind this was, first of all, that it was inspired by a Tidy Tuesday data set. You may or may not be aware of Tidy Tuesday, but it's kind of like a weekly data visualization thing in R where they post a data set and then people try to visualize it in different ways. So I saw this one last year about dog breeds and their different characteristics and how popular different dog breeds were. So that sort of inspired this. I also found an additional data set with breed sizes from the American Kennel Club as well, and I sort of combined these together to get a data set which I've called dogs.csv, and I've given it all, it had not great names before as well, so I've kind of tidied up the names. So that's the data set that we're going to be working with today. And yeah, here's the repository. And essentially my thought was that a lot of people got dogs recently, maybe during COVID or during lockdown, and including myself. And one of the things that I struggled with was, what dog breed is best for me based on the characteristics and what I want in a pet. So that's essentially what we're going to be working from today. That's the kind of example app. So hopefully you're able to get that from GitHub. This is, I've just got a summary of the data set so you know what it looks like. So essentially it's got these columns. So it's got all the different breeds, it's got weights, it's got basically ratings on how their personality traits fall on a spectrum. So it's kind of like affectionate with family, A 5 would mean the dog is like all over you and like like up in your face and very affectionate, and 1 would be that it doesn't really want to speak to you. So that's the scale, and that's kind of how the scale works for all of these traits. And then finally we have rankings as well in terms of popularity and how popular that dog was in different years. So that's what our data set looks like. So the very first app that I wanted to go through was an app to help you choose a dog breed, which is the problem that I sort of talked about earlier. So the idea would be that the user inputs different dog traits, and then the app is going to output a table of popular dogs with those traits. So that's the idea. In practical terms, we're going to use a checkbox for different breed sizes, so small dogs, medium dogs. We're going to have a select input for different coat types and sliders for the personality traits. And then we're going to use the data table package, which you may or may not have heard of, but essentially this is going to generate a table on the Shiny app, and it's going to show the top dog breed. So let's get into that. So if you have a look, hopefully if you have the files here, this is referring to app number 1. So let's move this along a bit. Okay, so here's our app. The very first thing is we're going to load in some packages. So for this, if you don't have it installed, I recommend installing DT, which stands for data tables. And that's going to be a package that we use, Dplyr, Shiny, and ggplot2, which you hopefully have already. The very first thing is we're going to read in the dog's data frame. So I've already read it in. So we've got it here. Now you'll notice that this is all before we actually start with the user interface. So this is it's described as the global sort of session. So it's basically stuff that's going to happen before anything else. And quite often you would read in data at this point, unless you want something to be only read in when a user does something. But we need this data right from the very start of our app, which is why it's kind of outside of the reactive context. It's right at the very beginning. We're reading in this data frame. So again, we're going to have a fluid page. That's going to be our how we start off the user interface. We're going to have a title again, using the title panel function. Dog Breed Explorer is what I've called this app. Feel free to rename. Again, we're going to stick with the sidebar layout because that's what we've been familiar with so far. This time we're going to use a checkbox group input. So let me show you. So checkbox group input, essentially it's a group of checkboxes. So you can have just one checkbox if you want a yes or no. This is just another sort of input that's got multiple checkbox options. And then we have what's called a select input, which is kind of a drop-down option. And as you can see, both of these are very familiar. So they both have an input ID, they've both got labels, they've got choices, and they've got a selected option as the default that's going to appear. And in this select output one, I have to define, so you'll see if I have a look at the arguments, you also have to define whether you're allowed to select multiple, which is what this argument here is. So I've put that to true because I want people to be able to pick a couple of different options, and this is for the type of dog coat, for example. Then we have a header. Again, H4. The biggest header is H1, just for your reference. So the higher number you get, the smaller the text is. And this is going to be personality traits. I've got some descriptive text about that as well. And then we have some sliders. So this is the same as our initial app earlier on with sliders. where we have an input ID again, a label again, minimum, maximum value, and the value that's going to be there initially. The slight difference, I guess, versus earlier is that this is a range now, so it's going from 1 to 3 rather than just a single value, because that makes most sense for this particular app. So the final thing I want to point out is in this main panel, we've got a data table output showing the most popular dogs. But for the moment, I'm actually just going to comment out the server just so you can actually see what the app looks like without going into the reactive elements of it. So yeah, so as you can see, that's our checkbox group input, that's our select input, so you can remove these, add them back in. And here are our sliders as well. Here we go. Okay, so let's bring the server back and talk about this a little bit more. So I'm going to add a browser here again, just so that we can have a look at this in a bit more detail and see what's going on. And then we'll discuss what's happening. So let's run this again. Okay, get into here. Okay, so essentially what I want this app to do is, based on these input values, I want it to filter that dog's data frame that I've brought in, and I want it to then display that in a table. So that's what's going on here. So this is essentially filtering all of these columns to be greater than or equal to, and I'll explain this, the first input on this slider. So if we look at openness level, you can see it at the moment, it goes from 1 to 3. So if we have a look at this input openness level, let's have a look. You can see that's how it that's actually what's contained within it. So there's really 2 elements there. There's 1 and there's 3. So that's why when I'm filtering, I'm saying I want it to be greater than or equal to the first one, which is 1. And then I also want it to be less than or equal to the second one, because I want it to be between 1 and 3. So hopefully that makes sense. But that's what all these filters are doing. I'm also filtering so that the size category is within the input size. So remember, that's our checkbox group input, and we also have the quote input, and that is filtered here. So we've got the quote type, input quote. We're selecting the 2 columns of interest, arranging them by the ranking. So number 1 is like the most popular dog, and number 200 is the least popular. And then we're displaying it in a data table. So let's run this so you can see how it looks. So I'm going to filter that. We've got 62 dogs that meet that criteria. And then we're going to render a data table. You can see it in this viewer, how that table looks. There's a few different reasons for using data table. It has a lot of customization options, which I won't go into today, but you can do lots of cool stuff with the data table. It's actually it's a JavaScript library that's been adapted for Shiny apps and R. So it's got some advanced features over other tables. You can sort by columns as well. So you can arrange by alphabetical order. You can search for things. It's got pagination, as you can see. So there's lots of reasons, but that's why I'm using this data table function. Yeah, and I've set the page length to 10 originally, but you could change it to 20 if you want to see more breeds on the same page. So let's see how this actually functions. I'm going to remove the browser just so that we can actually look at this. Hopefully, yes. Okay, so that's it functioning as expected. So we can move these sliders. Oh, there's no dogs in that category. You can move these sliders and see which dogs meet your criteria. Although I have to say, with all of this, dogs are, you really can't decide based on this. So please do not use this app for choosing a dog, because they're all different and you have no idea what you're going to get. But anyway, it is quite fun to look at. Okay, so that's our sort of simple app. I'm going to close all of these tabs and stop it running, hopefully. Well, it doesn't want to stop running. That's great. It should stop running, but I might have to terminate it. It's not happy for some reason. Okay, that's fine. It will come back, hopefully. In the meantime, while that's hopefully sorting itself out, yes, just terminate. Let me move this along. So the second app we're going to make is on the same theme, but we're going to be comparing 2 or 3 different dog breeds. So it's kind of a different use case. So rather than putting in the traits that we want our dog to have, we are putting in a few different choices and then comparing them.
We've just had sorry, Caitlyn.
Yeah.
We've just had a question on Slack. So it's actually 2 questions. So one is explain a bit more in detail the link between input and output ID on the server side and the app side. So I think it's just go through that again. And the second question is documentation for the different inputs we can have. So sometimes slider, sometimes selection. I can dig up the documentation and post the link in the chat while you're talking through the first question if you want. And question 3 was, will you always use a fluid page in the UI input?
Okay. Yeah, all really good questions. So I guess, yeah, Chris, if you could post the link to all the different inputs, because essentially there's like a page that has all of this information, and I always have to look at that page to remember which, like, I never remember any of this. So yeah, there is a lot of documentation on that, and it's more about just knowing, oh, I think there's an input that does this, and then you find the code for it. For the inputs and outputs, so I'll try and go through that again, but let me know if I'm not being specific enough, because I'm really sorry. I don't know why this is like decided to crash at this exact time. Let me refresh the page actually and see if I can get it back functional. I don't know why this is randomly. Oh dear, give me a second. This is a slight like.
I think we've maybe lost Caitlyn. So bear with us while we try and get her back. I'm assuming her internet's gone down or something. So just bear with us. I will try and answer some of those questions while Caitlyn's.
Am I back now?
You're back. Excellent.
Okay. Sorry about that.
No, that's fine.
Okay, so I wanted to talk a little bit more about.
You need to share your screen again.
Oh, of course, yes, that's the main thing. Okay, entire screen. There we go.
Let's find the shiny documentation.
Okay. So yeah, inputs and outputs. Let me know if this still doesn't make sense, because I'm happy to explain in more detail. But the question referred to input IDs and output IDs. Is that right, Chris?
Yes, it was. What was the link between them two? Yeah.
Okay, so essentially every input must have an ID and every output must have an ID. So you can see here within this app, we've got input ID size for the checkbox group input, and then for the select input for the different dog coats like curly, blah, 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 we have an input ID of coat. And I've just made this up. This is just my own personal like ID for this. So you make these up, and then the same for the sliders. So they all have input IDs. And then in the data table output, and this is maybe what I didn't explain, is this also has an input ID. So let me stop this. Let's have a look at data table output, and you'll be able to see. Oh, come on. Oh, Okay, it doesn't actually have, it links you to the website on it. But essentially, if I do that, maybe this shows you the arguments a bit better. So you'll see there's an output ID. So it's essentially the same. You have to give them an ID for all the inputs and outputs so that when you are in the server, you can refer to them. That's really the whole reason behind it, so you can refer back to them. So I'll actually put that in here because it's not super clear. So that's the output ID pop table or popularity table. That's just what I've chosen to call it. There's other options. Obviously, you can change things like the width, the height, all sorts of other things. But I'm just going to stick with this for now. And then if we go to the server, you'll see that I refer to this with output $pop table. So that's basically saying for this output, I'm going to render a data table. That's basically like how that is referred to here. And you can see the input is referred to in the same way with the input and then $ and the input ID. So hopefully that makes slightly more sense in terms of how they are connected, but let me know if it doesn't. The third question was about the fluid page. Yeah, so it's not the only, it's not like the only way, I don't think, because you can get really complicated apps that use different, how would you describe it? I have some slides on it later. Like you have things like shiny dashboards, and I'll discuss more later, but it's essentially different frameworks for writing shiny apps. So they definitely don't all start with this fluid page, but I think the apps that we're going to be talking about today do, because that's just generating a simple page, and then you can still within that customize the layout. So whether it's a sidebar layout or the fluid layout I was talking about earlier with the fluid rows and the columns and all of that sort of stuff. So it's definitely all you need to know about initially, because it can get you a really long way.
And there's one more question from someone else. So it said a mutually dependent select input to filter a data set. So this person uses selectize group UI, but are there any different or easier methods?
Select eyes group UI, that is, I think, do you mean
it's on the shiny widgets packet, I think?
On the shiny widget, yeah. You're saying, is there any better ones versus that? Is that the question?
Yeah, in order to have a mutually dependent select input to filter a data set. So I'm guessing one that, and sorry, you might need to clarify this if you're watching, but I'm guessing that's one that will decrease the available inputs if your other filters have.
Like it changes based on your other
inputs.
Yeah, there are different ways to do that. I have some slides on it later, but essentially you can update the options that are available within different sliders, within different inputs, sorry. So like the choices, at the moment we've specified them manually, and we've said we want it to be, and I maybe should have explained this, but like we want the choices here to be unique dog coat type. So if I just print that, like that's what we want the choices to be, or you can type them in. But there are options where the choices can be reactive. So that's maybe something to point out, but we're not going to get into that yet. But that is an option. So there's lots of stuff you can do here to make it more dependent on various things. Like if you said yes to an earlier input, that's going to affect a later one.
Thank you. I think that's it for the questions we've got so far.
Okay. Let's move on to app number 2, which has introduces another concept. So yes, as I said, app number 2 is going to compare different dog breeds. It's going to have an input of multiple breeds, and then it's going to have 3 visualizations about traits. So if we have a look at this, we're going to have another select input. We're going to have the unique dog breeds as our choices. We're going to select 2 of them as well. So that's what this is, basically, so that the app starts with something there. That's the reason. So it's going to start with these two breeds, and you're going to be allowed to pick multiple as well. Within the main panel this time, we're going to have 3 plot outputs. So you can see here, I'll put output ID equals personality. Oh, not in tab panel, sorry, that's me getting confused. So there's a couple of things going on here. So the first thing is, within the main panel, I've also added a tab set panel. So this is basically, and let me get rid of the server for a second so I can show you this. Hopefully this still works a bit. So we've got the sidebar, but we've got, I just wanted to sort of illustrate a slightly different layout option. So you can see here we've got what's called a tab set panel, which is the thing I mentioned earlier in the slides, where you can have like multiple tabs within the one kind of bit of the page, essentially. And that's what's happening here. So we've got 3 different tabs that at the moment don't show anything, but they're going to. So within the first, and another thing that I just want to point out as I'm going through this, there's so many brackets involved, and that's like the biggest mistake I make all the time in Shiny, is like making sure all the brackets are closed. It's just a nightmare. But, you'll see there's a lot of brackets even for a relatively simple app, because each thing is a function within a function within a function. But you do get used to it. So within this main panel, you'll see I've got this tab set panel, and then I've got 3 panels, and these are essentially, you'll hopefully see if I have a look at the tab panel function, you'll see these are the titles of each of the panels. And then within them, I've got a plot output, and I've got 3 different plot outputs. As you can see with this, output ID for the first one, radar, personality, which will make more sense in a minute. Output ID for the second one, bar characteristics. It's not actually a bar plot, so I don't know why I called it that, but that's what I've called it. Output ID equals popularity for the third one. And I've specified some heights and widths as well, of just like how big these outputs should be. So that's what's in here. So if we move over to the server, there's a couple of things going on here. So what do we want? We want to change these outputs based on this breed selection. And if we think back to what we just did in the previous app, what we did was, based on the traits, we filtered the dog data frame, and then we used it for our table. That's what we did. So we could do that here. We could, and this is within the radar output, so it's going to generate a radar plot. Render plot, we're quoting it with output radar personality here, which links back to this plot output here. That's what we're doing. So what we could do is we could get the dog's data frame, we could filter it with the breed that's in input breed, because that is our input ID for this select input. So we could do that. And then we could ignore that just now, look within this radar plot part. So we could do that. Then we could use that to make the radar plot. So that sort of makes sense. The issue that we have is, and here all that's happening is we're just getting specific columns that are of interest to the radar plot code, which you don't really need to know for this Shiny tutorial, but this is just generating a radar plot. So that's one way to do it. The issue is that we have 3 different plots here. So we have, and I'm just going to remove this again so that I don't forget. We're going to have a radar plot. We're going to have a bar. It's actually a lollipop plot. and we're going to have a line graph showing the popularity over time. So what it means is like we'd have to do that same filtering process, taking the dogs data frame, filtering to only include certain breeds 3 times. So it doesn't, when you think about it that way, it doesn't make an awful lot of sense to do that. And there is an alternative, which I just want to point out. So we can use something called a reactive expression. So a reactive expression is essentially, it's something, it could be an object, and it essentially responds to changes in input. So the code within a reactive expression will update as soon as the relevant input changes. So similar to all of this stuff with the plots, you know, rendering a plot output, this in itself is reacting to changes in input, but we can have a step before then with the data so that it responds to changes in input, and then we can actually use it within this these render plot functions. And I've got a diagram that hopefully will explain this in a bit more detail, but this is really useful so that you don't have to recalculate an output each time an input changes, because just from a computational perspective, if we have to do this filtering 3 times here, it doesn't really make sense, because we want all 3 plots to be reading from the same, they're all going to be doing the same thing with the same data. They're just going to be generating different plots from it. So if we look at this, oh no, I want to change these slides. If we think about an input, so that's our breed selection. In our sort of old way of doing things, what we'd have to do with that input is we'd have to do 3 separate computations, and then those 3 separate computations would lead to 3 different plots. All these 3 computations are basically doing the same thing until the point that it's used by the plot. But yeah, this is a very, it's going to take more work to do this, essentially. What we could do instead is when an input changes, we could have a reactive expression, which is 1 computation. So if we imagine, it will basically create a data frame that will have those two breeds selected, and then we can use that within our outputs to generate the plots. So it's removing a couple of extra computations that we don't need. So let's have a look at this in practice. Over here, I move this over again so you can see. So this was our old option, which is not a good option. Instead, at the very start of the server code here, I've put this reactive data frame essentially. And what this is, so you'll see it's using the reactive function. And this reactive function is basically just creating a reactive expression. That's what it's doing. So you use these, the opening brackets, and you also use this curly bracket to sort of indicate reactivity. So if we can have a look at this function in a bit more detail, I think, if it's going to let us, let's see. Yeah, so create a reactive expression. And there's a bit more detail about it here. But what we're actually doing within it is we're taking the dogs data set, we're filtering it so that the breed is within this input breed dropdown. And that's all we're doing, because that's done everything that we actually need it to do. So essentially, this is, for all intents and purposes, it's basically like a data frame that's just filtered. But we refer to it in a very special way going forward, where we actually use it as though it's a function. So you can see this selected dogs double brackets. That is referring back to this reactive data frame. So that's what's happening. So we can just use this reactive data frame now that's already been filtered for our plots. So if I'll remove this because this is not how we're going to do it. If I browse here, just so that you can see what's happening, I'll get rid of the other stuff just now, so we don't need to think about it. Let's just look at the radar plot. Hopefully this works already. Let's see. Okay, so it's taken us into the code. So you can see this selected dogs data frame. If we have a look in the app, you can see the 2 that are selected by default happen to be Belgian sheepdogs, and I don't know what they look like, and French bulldogs. So if we have a look at this selected dogs, it won't print out into the console, I don't think, no. So, but if you assign it to an object, then you can actually look at it, and that's what I tend to do in these situations. So if we assign it to an object A, then you can actually have a look at it, and you can see it's basically just a filtered data frame in this case with those two dogs. So then we can use this, we can select the relevant columns. This doesn't matter so much because this is just creating a nice radar plot. And yeah, let's have a look at that now in the app. So I'll just get rid of this browser and let's have a look. There. So as you can see, let me zoom out slightly so you can actually see it. So yeah, that's basically, it's filtered for those two dogs and it's generated this radar plot. Now, when this is really useful is when we're going to use multiple plots as we are, because we want all three of these to be using these two dog breeds. So if we, let's add another one in. So this is our another render plot for bar characteristics, which I refer to here. So it's the second in the in this set of tabs. Again, doesn't really matter what's going on here, but I'm essentially just selecting the relevant columns from the selected dogs reactive data frame here. And I'm just, yeah, I do some extra stuff to change the names of things, but it doesn't really matter. That will generate a lollipop plot showing the differences between the dogs. And then again, popularity plot here is doing the same thing. It just brings in the selected dogs, already filtered data frame, and generates a line plot. So now you can see if we go to the app, you can see all three of these now are using the same two dogs. And if we change that, so we can add in another one, although it gets a little bit complicated to see. Let's add in English Cocker Spaniel because they're the best. So now we can see three different dogs. That's updated and that's updated. So that's kind of how that works and how you can save yourself some computational time. Okay, so that's I think that's all I wanted to say on this app. I don't know if there's any questions just now before we move on to the third app. It might be a good time to ask them if there are any.
I've not seen any on Slack at the moment. There's none on Zoom, and I don't think there's any on Twitter either. So there is about a 15. Oh, there is about a 15-second lag between YouTube and us. So one may pop up at some point, but I've not seen anything now. So
okay.
I would say, yeah, I'd say carry on, and I can always interrupt you if there's something pressing.
Yes. Cool. So that's us made two apps now. The third app is going to.
Oh, there is a question. Oh, there is now a question. It's all right. It came in while I was looking away. Can we get the link to the design choices? I don't know.
Choices.
I don't know. You might need to clarify what you mean by that, and we can answer that.
Yes. Yeah, I'm not 100% sure. If you mean the code, yes, absolutely. But I don't know if that's what you mean.
I guess it's just sort of maybe say that, you know, the default shiny widgets are. Oh, do you mean those themes?
Maybe. Oh, different
options for inputs. Oh, sorry, no, that's me. That's me. I posted it on. I posted it on Slack and not on Zoom. Sorry, I will. Yeah, I'll do that.
Yeah. Okay. Yeah, all the different options, because I feel like in this talk, I more just want to highlight, like, there are all these different options, and then you can go away and pick, you know, all of the options that are of interest.
So the link I've sent includes all of the different built-in Shiny control widgets, but there are more available through other packages, possibly beyond the scope of this, but I don't know what Caitlyn's going to do. But yeah,
there is a bit later on making, like, leveling it up and not just using the default stuff. So yeah. Okay, so we've built 2 apps, and this third app is going to basically put the first 2 together. So hopefully you'll be familiar already with a lot of the code in it, although it might look long when you first look at it. So we're going to create a multi-page app that also has a theme. So it's going to look a little bit nicer. Oh, I keep going on to the next slide. So it should also look a little bit nicer, because I hate the default Shiny like page personally. So we're going to merge the first 2 apps into one, and we're going to make it look nice. So if you enjoy that sort of thing, this will be fun. So I've opened up the third app here. So this is app number 3. Let's move that along a little bit. So the first thing is we're going to create an app with 2 pages. So, and it's already done for us, again, because I didn't want to code at the same time and make a million typos. So here's navbar page. So this function, again, you can find this online. There's a whole list of all the different layouts that you can use. I'm just highlighting it. And this is a navbar page, and it essentially looks like this little visual here, where it puts different pages at the top with headers. So if we have a look at what that function is actually doing, you can see the first argument is title, and yeah, it says create a page that contains a top level navigation bar. And yeah, the first thing is a title. So Dog Breed Explorer is our title still. I want to point out this is different to the previous app already. Remember, we had title panel before. That is gone. Now we have navbar page. So that's the difference already here. We also, another difference is this tab panel. So that comes from the navbar page. So if I run that again, if you look at the examples within this, you'll see it's got the page, and then tab panel is essentially the first page, and then you have another tab panel, and that would be the second page. There's also extra things you can do, like menus, which gives like a drop down option on the page, but we're not gonna, we don't have that many pages, so we're just gonna keep it simple. So this is the first page, Explore Dog Breeds, and that is essentially our first app. So you'll recognize that with the side panel and the main panel again. And then we've got page 2, where we compare our different dog breeds, and that is our second app. So we've just put them together. The server, we've just dumped all of the server code in here. May or may not be obvious at this point, but the user interface, it really matters, the order of the code. The server doesn't really matter too much, the order of the code, because it will just, the app based on the inputs will look to the server and perform a computation when it needs it. So it doesn't really need to be in a certain order. So you don't need to worry too much about that. I've also added a theme, but I'm going to get rid of that so you can see it without the theme first. So just pretend this isn't here. Pretend that's not there, and we'll run the app. Let's see. So now we have a navbar page. Oh, I've also added images, which I will discuss. I just wanted to see what all the dogs looked like. So we can chat about how to do that. But essentially, it's, other than that, it's the same as the first app that we made. And then this is the same as the second app that we made. So we've just combined it into one. And it already looks better and more sort of polished. The next thing we're going to do is add in a theme. And this is really easy. for the basic set of themes. So there's a package called Shiny Themes, which is very well named. And within that package, there is a whole bunch of different themes here. So you can just have a look at that website. There's loads of documentation about it. I think there's maybe 12 initial themes. Most of them are shown here. I like the one called United for this app because, and I don't actually know if it's shown here, maybe there's 16. United, basically, it's kind of orange. So I just like the look of it. So let me show you what that looks like, and then I'll change it and you can see what effect that has. So all I've added here is within the fluid page, you can see there is an argument for theme. The default theme is no theme. So here we've added theme equals shiny themes, the shiny theme function, and united. I think within the function, actually, it might list all the themes that are possible. No, it doesn't, but you can have a look on this page for all the, oh, there. So these are all the themes that are available. So let's run that. And it looks much nicer and more polished already. So that's one theme. You can see it even changes the text and lots of other things as well. Let's do another one, Space Lab. Let's see. Great. So that's another option. Okay, I'm going to keep this one because I like this one. Okay, so just another, again, minor point for people who like to make things look nice, like me. If you want to add things in like icons, that's very easy to do. There is a package called icons. And within that package, you can essentially add icons. So like at the very start of the page, like this explore dog breeds, for example. In fact, I'm not even that sure if it works at the very first header. I can't recall if it does. So let's put it here in this H2 breed characteristics title. So if I put here icon paw, and I know there's a paw icon, which is why I'm able to do this. But you can have a look at the actual function. It gives you a little bit more detail. And there's a whole list of icons you can use. Let's have a look at that. So it's added a paw there. So that's a simple thing you can add to make your app a bit prettier. I didn't realize the images were in this app, so I better explain that slightly. So as you can see in this data table here, remember it's created with this render data table function. We were filtering based on all the things, and originally we had breed and 2020 ranking, popularity ranking. Now I've added in image. So this is actually in the dogs data frame, just to point out. There is an image column that basically links to images of all the dogs. So I added this in, and you'll see if I don't have this last bit, you'll see what happens, because it's not as simple as it might appear initially. So if I just leave it as it is in the data frame and add it to the data table, it will appear like this, which is not that useful. So what I did was I essentially mutated that and I pasted in. So this is HTML code. I know basically nothing about HTML. I actually asked ChatGPT, how do I add an image in HTML? And it told me that this is what I should do. So basically it's like a start tag, and then you add the image link, and then you can specify a height, and then you put an end tag there. So this is something I didn't know how to do. I just Googled it. So, but it really, the reason for showing it is that it shows that you can integrate things like this into Shiny apps. So you can add HTML code, you can add CSS, you can add JavaScript as well. And And if you don't know those things, I do actually recommend asking ChatGPT, because it does seem to know about how to do basic things in HTML or JavaScript. So that's what this is. And then within the data table function, a final thing to point out, just relating to those images, is I added you'll see this within the package. There's a parameter called escape, and escape is relating to HTML. And basically, I don't want to escape it because I want it to actually use that HTML code and generate an image. So that's why escape is false here. I've tried to document that. So hopefully that makes sense. And it gives you these really nice images, which is cool. Oh no, I've got the worst error it's possible to get. Oh, okay. I just forgot to add this. Okay. So yeah. Now we've got our nice images and we can look at all the dogs. So that's nice. And that's another reason for using data tables, is it lets you do this kind of cool stuff that other tables don't always let you do. Okay, so I think that's it for the third app. I do have a fourth app that has a little bit more reactivity and a few more advanced features that I can go through now. I don't know if there's any questions at this point, Chris, or whether I should just push on. You're muted, but you look like you're saying
that's really helpful, isn't it? Sorry, I've not got any. I've been keeping an eye on Twitter. There's none on Twitter at the moment. None on Slack. So let me check YouTube. None on YouTube either. But I have one. I guess that might help clarify. You know the little percent with the angle bracket and the percent thing. What does that mean? Just for other.
Oh,
the thing that caused the error.
This.
Yeah.
This. Okay. Yeah. So this, I am very I use a lot of tidyverse in my code. So this is just the dplyr pipe basically that's going between everything. So you start off with this data frame, and all of this is kind of like piped together using a I don't know how to even explain it. I'm like, how do I explain dplyr? I learned R only in tidyverse, so actually all of the base functions I know nothing about. So yeah, that's what this is basically. It's just the pipe, and because it was broken here, it just had no idea what was where this image column came from. So that's why it broke. And I have a slide on this shortly, but Shiny is not that helpful. When code breaks, it doesn't tend to give you the most useful error messages. So yeah, that's something to be aware of as well. Okay, so that third app, it looks better than our earlier apps, but there's actually two issues that I wanted to fix. So the first thing is that, and you've probably noticed, like every time this changes, that table recalculates. Maybe that's a good thing, maybe that's a bad thing. If this was pulling from a database, like every time you change the filters, that would be really costly in terms of computation, like every single time. And what if you actually want a very specific dog with like high energy levels and high barking tendencies? Why would you want that? You know, you want specific filters, and you won't get to them all immediately. It doesn't make sense to update that quickly when you're still trying to configure your options. So what would make more sense here is actually to have some sort of button to say like submit these options, now filter the data frame and like get this and generate this output. So that's what I want to add into this app. The second thing I want to add in is if we go to this compare dogs page, there is a slight issue, because if you add more than 3, it gets a little bit, I mean, the first thing is it gets very hard to interpret, like there's too much going on. And also because of the way that I've written the plot functions for these, they're aren't enough colors, so it will actually come up with an error, I think, or it should. It should come up with an error. Or these just won't generate at all, which is sometimes what happens in Shiny when there's a problem. It doesn't tell you what the problem is, but it just doesn't actually work. So we don't, okay, there are insufficient values in manual scale. And that's actually talking about the color scale. So basically these plots don't really work properly when you select more than 3. So we want to be able to tell the user that, so that they don't make this mistake. So in this 4th app, it's going to get slightly more complicated. And the first thing I want to do is this, to stop it recalculating every time the slider changes. So let's think about that. So we've got these slider inputs here, remember, and they are, if we search for that openness level, it's going to be in the server somewhere. So it's here. It's generating this rank table. And you'll see what I've added here is this isolate option. So if I just stop that. So this was the old code here, and this is the new code. I've basically added this isolate, which we can use to basically halt a reactive expression or to stop a dependency. So at the moment, what happens is every single time input changes, and this is the old code, every time this changed, this whole thing would rerun again, and you would get a new value and it would recalculate the table. We want to stop that happening. So we've added the isolate here, and this isolates this input and stops it recalculating based on that. So if I just show you that first, what that actually does, just adding this to these inputs and make sure that nothing else comes up. Okay. So now you'll see, now I'm moving these and nothing is happening. Okay, so it stopped that reactivity. Okay, so that's what the isolate function does. So if we go back to this, what we actually want is to add some sort of button or option so that users can say, I'm done making my selection, filter it now. So we can do that in a few different ways, but how we're going to do it is an action button. So we've added it here. So this is, again, one of the sort of standard inputs that you can use, that you can read about, and it's essentially it generates a button similar to all the other inputs. It has an input ID. I've called it Go Button, and it's got a label, which I've said filter dogs. That's going to appear now. Run that and see. Great, so that's it. That's it there. Doesn't work yet. So now we need to make that actually do something. So within this render data table function, all we actually need to do is add this input go button in here somewhere. And because we haven't isolated this, it means that every single time the value of this input button changes, then it's going to re-execute this table. And that's basically what we want to happen. So you can see this in action. Let's have a look. So every time, so let's actually make some changes here first. Okay, small dogs with high energy levels. Let's see, and now that's filtered. So you can see how that's maybe a bit nicer for someone to actually interact with as well. Okay. Yes, so I think if you have any more questions about that, I can go over it in more detail, but that's essentially, that was the main thing I wanted to show there. It's just how to halt reactivity and how to get it to like run again based on something else. So we're adding a dependency on the input go button, and then that's going to make that all run basically. Okay, the next thing I wanted to talk about was this feedback, user feedback, when they enter more than three, breeds into that second part of the app, so that the plots actually work. So in that instance, let's have a look at the radar plot here. So how this works, I mean, there's a few different ways to do this. Again, like everything is Shiny, but I thought we'd use the Shiny feedback package. So this is a package, and it has a its main sort of function is this feedback warning. And what that generates is something that you can see here. So these are all feedback warnings. So like this is a text input, and if you type in a certain thing, it comes up with this like warning symbol, don't do that, and tells you what's wrong. You can use this on lots of different inputs, basically, and tell it when a user does something that they're not supposed to do, or enters a, like, I don't know, letters into a text input, into a numerical input or something like that, it will come up with a warning and tell them what to do. So that's the thought behind this. So how we actually do that in the code is within this radar plot, we can add, you can see here we've got the Shiny feedback warning. We have to refer to the input ID of the input that we're trying to warn on. So remember, it's the breed input that you select different breeds. That's the one that we want to flash up with a warning. Now, the logic behind it is slightly more complicated. So let me use the browser and actually get in here so you can actually understand what's happening. Okay, let's go to this bit. Right, go back to the code. Okay, so remember this input breed. At the moment, we've got Dachshunds and French Bulldogs. Okay, so let's just have a look at that. Great. So how Shiny feedback works is essentially it's asking for, how do I explain this? It's like a logic based on something, and it has to be true or false. Like when this is true, then show this warning, basically. That's how it's working. And essentially it's checking, is this true? This more than 3? And I'll talk about what that is. So I essentially generated an object called more than 3. And that object is when the length of input breed is greater than 3. So at the moment, the length of input breed is 2 because there's just 2 dogs. But so for this whole thing, length input breed greater than 3, it's going to evaluate to false because it isn't greater than 3. False. If I add another one in, so let's add a couple of other dogs. Let this reevaluate. Okay, now if I run this again, length input breed, it's going to be 3. Oh, just 3. Oh, sometimes you have to run it because it adds each one separately. So now it should have added all 4. So let me run that again. Okay, so now it's 4, which is definitely more than 3. So if I run this length input breed greater than 3, it's going to say true this time, which means this more than 3 object, you'll see more than 3, it's going to equal true. Okay, so that's just me creating an object with a logical value. So now in this Shiny feedback, I've put in an input ID relating to this, basically. It's going to be shown when more than 3 is equal to true, which in this case it is. And then the text is going to say, please select 3 or fewer breeds to compare. Okay, so let me show you how this works in action now. Hopefully, I haven't forgotten to do anything else. Let's see. Okay, so I'll add in some more dogs. Okay, so I've added in 4, it's came up orange. It says, please select 3 or fewer breeds to compare. And it's kind of, yeah, signaling to the user that they need to do something. So that's just another way to bring in sort of more reactivity and more, it just makes the app a bit more user friendly as well, because they'll understand why it's breaking essentially if they do something. Okay. Oh, wait. So yeah, so that's me actually finished going through these apps. I have a final app that's online. If you want to have a look at it, I can share the link at some point, but basically it's like the 5th version of this app, and it just looks even slightly better than this, and it's got one more plot, and it was just kind of to illustrate the progression of this app through different stages. So hopefully that's been useful. Now sort of coming away from this workshop, and I do have some more slides after this, but I just want to set all of you a challenge now, kind of leading on from this workshop. Not everyone likes dogs. Some people prefer cats. I'm not one of those people. But just for balance and to make things sort of fun going forward, I have put a cats.csv dataset in the GitHub repository. And what I would love for you to do is to use this dataset to build an app all about cats, if you want to. Essentially using like similar logic to what I used. You can use the dog apps as a sort of template to help you and like get some ideas. The cats dataset is actually quite similar to the dogs one, which is good. Like it's got similar sort of sliding scales for different personality characteristics. So I think it should be quite similar. So you should be able to adapt some of these ideas, but it just gives you a new data set to play with. So use it to build an app. I change some of the inputs and outputs, play around with themes and layouts, consider reactivity and user feedback, and try to integrate some of these cool features that I've mentioned and that I'm going to mention in the next few slides. And please also, if you could share it, that would be so great, sort of coming away from this conference, if you were to share it either somewhere on the Slack or on Twitter or however, GitHub, however you want to share it. It'd be really cool to see all the different iterations of this app. Yeah, so I'd love to see that, even though I don't like cats that much. So yeah, please do that and try it out.
I, however, have 2 cats, so would be more than happy to see all of your cat filtering apps.
Yes, you might be more pleased to see it. I'm pleased to see the shiny in action, but yeah, take or leave the cats. But yes, some of you might like it more than the dog one anyway. Okay, so I've got a few more slides to finish up. One important thing is about sharing your app with the world. So if you're actually going to make this cat app, you might want to actually share it somewhere. I personally don't have much expertise outside of shinyapps.io. That's where I share all of my apps. I know that you can you can use your own like web server. You can also host them on GitHub. I think the easiest for a beginner though is probably to share them on shinyapps.io. I've just taken a screenshot of the shinyapps.io page. So like if you just search, Google it, you will end up on this page and you can sign up, and it has step-by-step instructions. So it's really, really easy. It'll just take like 5 minutes to follow through these instructions, and then you can deploy it to a website and share it with the world. And as long as your app isn't super complicated, you can get away with the free version for a very long time, unless you're in the future, if you're like, I don't know, pulling in lots of data and it's really complicated, you might need to upgrade to a paid version. But for the cat app, you can definitely get away with it being free. So please do that. I wanted to just touch briefly on debugging Shiny. I mean, luckily I didn't have to do it too much today, but it can be really challenging because, as you've probably realized with me going through the code, Shiny isn't like an R script where everything is logical and in order. It jumps around. So whenever you click something on the input, or even when you navigate to a different page or, you know, a different part of the app, it will go to the server and get that specific bit of code and then, you know, generate something. And it can be very difficult to logically like even understand where to put a breakpoint in the code or where to put that browser option. So it's just something that you get used to, but it is challenging, definitely more so than debugging an R script. Error messages, again, are not always informative. They don't always actually tell you what's wrong. So some of the top tips I have are to run code outside of Shiny first. So just to give like an example, so for within the server here, for example, when I was creating this code, if I go to maybe this one, what's an easier one? Probably, yeah, this one's fine, I guess. This one where I'm filtering a data frame based on the inputs. Like even this, for example, I quite often run this in a separate script or just run it within Shiny but not in Shiny. And what I would do is, like, instead of having input openness level or whatever input you have, I would just put a character value or whatever value you expect your input to take, and just check that the actual code works and it's not something about your code. So that's what I tend to do all the time, is just like run these things with fake inputs, basically. I find that really useful. Another tip is to press this run app like constantly, because every single change that you make could break it, and you don't want to be like what I've done in the past, is you write loads of code and then you run it and it's broken, and then you have no idea at what point it broke. So I would say, like, run the app every time you make like some change to the code, so that you don't end up in that situation because it's horrible and then you have to go back so many steps to try and work out what you've done. I've already pointed out using breakpoints and using the browser function, which is really useful to kind of get into the code and see what's happening at certain points. Another thing is just very simple. You can even get the code to print out things. So like here, you can get it to print the structure of the DF data frame that we've created, just to check that it has all the columns that you expect it to have, and it will just print it out into the console for you to look at while the app is running. And this can be useful to understand like which bits are running before other bits, because if something prints out first, you're like, oh, that bit of the code has just run and then this bit of the code is run. So I find that really useful, either print or message for that. Another option is to use this, so you can actually put it in the code. Let me get to a slightly simpler app than this one. So let's go to this app. If you type in options Shiny React log equals true, if you put that in and then you run the app, and then you press, I think it's Control F3. Yeah. So it like opens this thing, which, to be honest, kind of terrifies me, but some people find it really useful. And you can basically, this became massive, you can basically step through. So from the very start of your code, you can like step through each bit and like see, oh, I'm like not very good at using it, as you can tell, because I'm scared of it. But yeah, like the step here, so you can step through what's actually happening. So like for this popularity table, sorry, that was generated in the first app, you can see like all the things that are going into it and when they come into the interaction. Now this is a really simple app, but like with more complicated apps, this sort of visualization of when things are interacting and when things become what we'd call it is invalidated. So like when a reactive output is going to be changed based on an input, all of that can be useful. Just depends how you learn and how you get to grips with the whole reactivity side of things. So it might be helpful for you if you're quite a visual person and you want to understand all the connections. So that's another option as well. Let's move that back over.
Someone asked the question. I sort of answered it on Zoom in the text, but I thought I'd read it out. Someone said, how do you share your app in GitHub? Do you share only the code? And I've said, yeah, GitHub itself can't host dynamic things. You have to use something like Shiny App, but you can share the code on GitHub, and then people can download and run it themselves.
Yeah, that makes sense. I have seen people like share things where it's like GitHub, but I don't understand it. Maybe it wasn't a Shiny app.
It only supports static file hosting, so it's good for things like the package down instruction manuals that can be automatically generated, but it doesn't do things like Shiny that need access to data.
I see. Yeah, that makes sense. Yeah, I mean, I've only ever used shinyapps.io. I think there are other options, but I just stay away from them because I don't understand. But yeah. Okay. So these are just a few more slides. We've only got 15 minutes left. But these are just like things to consider going forward. So it's not, I don't think you'll understand all the things I'm talking about here, but it's more to just make you aware of like the sort of things you can do with Shiny and things to consider if you're going to start building Shiny apps for your own purposes. So the first thing is like, where are you going to store the data? So we've slightly touched on this, but depending like what your data looks like if it's image files, arbitrary data, all sorts of different formats, like it can be lots of things. You can share it, you can store it somewhere like Dropbox, and you can pull it into the Shiny app that way. You can use Amazon S3 or other I don't know if you can use Google Drive. You probably can. I haven't used it personally, but I imagine that sort of thing you can use and like link to it. You can also, so like for this dog app and your cat app, shinyapps.io does have some limit on storage for the data that you upload, but these files are quite small, so it should be totally fine. So you can also have stuff like you can have files in your filing system in your computer if you're running Shiny app locally. Or if you're uploading to shinyapps.io, if it's a small file, like a small CSV or something, you can just upload it with your Shiny app. If you have more structured data, you could use Google Sheets is a good option for beginners who maybe don't know much about databases. I've used Google Sheets before. It's really easy to link to that using the Google Sheets 4 package. You can also link to SQL databases as well within Shiny. So that's another option. And obviously, like I've never used this, but I know that if you have sort of semi-structured data, you can use other systems like MongoDB, for example. So there's lots of options that Shiny can connect to for external data. And this, I just wanted to point this out. This is a link to a really cool Shiny app that sort of shows it shows all different data inputs and how they like come into Shiny and how to bring them into Shiny in your code as well. So I recommend having a look at that if you want to know more about different data storage options. So how will you visualize the data? I showed a couple of options today, but there's so many plots and plotting libraries and all sorts of stuff that you can do. I wanted to point out you can make really cool interactive maps with a package called Leaflet. It looks really, you can like zoom in and hover over, and just lots of really cool things. And another plotting library I use all the time is Plotly, which is similar to ggplot in a lot of ways in terms of the different types of plot that you can do, but then you can hover over and interact with the plots a lot more than you can using just ggplot. So for example, this is, maybe I can have it, do I actually have it here, because I was meant to camera Shiny apps, not that one. Dog Food Explorer. This is like the final Shiny app that I put online from my work on this workshop. You can see like I added this page at the end, and this is a Plotly graph just to show you the sort of stuff that you can do. So like this is Plotly, and the difference is it's a bubble chart, but you can hover over, and you can have text that appears when you hover over as well. And another cool thing, just to show you quickly, is you can also do things like click and get things to appear based on like whatever you've clicked. So that's just to show you the benefits of using something like Plotly over the more simple ggplot visuals. An advantage of Plotly as well is you can use what's called ggplotly, which is a function that basically turns ggplot code into interactive Plotly code. And that's what I did for that bubble plot. So like within the code, and you'll see in the GitHub repo, this is app number 5, if you're interested. I basically created a ggplot bubble plot and then use this ggplotly to transform it to an interactive plot. So that's really easy, and you don't need to learn any new functions within Plotly to be able to start doing this. Cool. So how can you level up your reactivity? I just want to point out cool things you can do as you go forward with Shiny. I think it's just useful to know like this is possible. You don't have to implement it straight away, but you can do things like have plot clicks as inputs, as I just showed in that app where you click and a dog photo comes up. There's actually 4 different types of inputs from plots. You can do click, double click, hover, and brush. And brush is more like where you like get a square and like zoom in on a couple of things. Lots of options there. And they can all be used as inputs, and you can generate things from them in the server, so they can be used for computations, which is pretty cool. In the data tables package, you can use things like you can click the rows of the data table, and that also can act as an input and be used in some computation later. You can invalidate reactive things after a certain amount of time. So, for example, if your app was connecting to some external database and maybe that database was changing every, like, I don't know, half an hour or whatever amount of time, every 5 minutes, new data was there, you can set it within the app using this invalidate later function, like after a certain amount of time, stop this this output and actually regenerate it based on the latest data. So you can do things like that that can be very useful in certain cases. You can perform computations under certain conditions. So if you click this and click this, or when you've done this specific action, you can make something else happen. So it can get really complicated in terms of the reactivity, and there's just a couple of functions there that you can use for that. Someone mentioned this earlier about updating like the choices of things in a more reactive way. So like, you know, in this app, for example, maybe if I was going to make it really good, I would, if you only clicked small dogs, for example, maybe there isn't a small dog with like that's hairless, you know, so like this option wouldn't be there, is what I'm trying to say. So you can make it so that the inputs are reacting based on other inputs. So it's kind of like if you click small, maybe only 3 of the coat types would be there because only these coat types are available in small dogs. So you can do that sort of thing using the update select input or update whatever type of input, and that actually is part of the server code, which is kind of different. But if you're interested in that, have a look at those updating input choices. You can also have lots of different things in terms of conditional user interface components. So again, when you click extra large dog, maybe another option comes up. I don't know, I'm trying to think of something that would come up immediately. But basically, after you click on an option, another type of input would appear, for example. So you can do that sort of thing as well. So there's conditional components that can appear based on your selections.
So I've used that one on the Prisma flow diagram app. So if someone says true to an option, it adds another another set of number boxes, for example.
Yes, yeah, exactly. That sort of thing. That sort of thing is what it's useful for. I just wanted to point out a couple of things, a couple of resources. So there's this Shiny Awesome GitHub page. I'll see if I can get a link to that, or maybe you can, Chris, actually. But it's basically this GitHub repository of like all these amazing like Shiny extensions and like ways to make your apps look really cool. Again, if you're into that, you should definitely have a look at this. You can do really advanced themes as well. I just wanted to point out those 12 or 16 themes are not all the themes that you can do. You can make your own theme. And there's also this Bootstrap library package, BS Lib, I think it's called, where they have more recent themes as well, like because the old themes are based on old Bootstrap themes from quite a while ago. So they've got more modern themes like this. This one's called Minty, I think, and it's kind of a bit different, very pastel colors. So there's a whole other set of themes as part of that package, or you can make your own theme from scratch. There's loads of options there. Also just wanted to point out this Shiny Widgets package that I think someone also mentioned earlier. I use this all the time because I don't like a lot of the defaults. So you'll see like this button is a Shiny Widget action button rather than the default action button that we used earlier. They basically have a lot of the inputs that we've discussed today, but just like nicer versions of them. So again, if you're into that, I recommend looking at this Shiny Widgets package because it uses the same syntax as well, really, as the traditional Shiny input functions. Okay. Yeah, just wanted to say there's like loads of resources on all the stuff I talked about. If you are interested in taking your Shiny app the next step as well, like adding CSS or HTML, JavaScript, all of these other things, there's lots of resources on that on the Shiny website. And as I mentioned earlier, I have personally found asking ChatGPT about basic things very useful for simple HTML things, because I know actually nothing about that. So I just wanted to briefly just mention that there's other ways to build a Shiny app. There's whole sort of frameworks around building a Shiny app like a dashboard. And you can see there's the Flex dashboard package and the Shiny dashboard package, and you can make apps that look sort of more like a professional dashboard. You can have, they essentially have like these boxes that you can put plots in or inputs. So they look quite different to the more traditional Shiny apps. So it's just something you might want to be aware of as well if you want to get into this a bit more. How can you scale a Shiny app? This is probably a bit beyond like what you're thinking about just now, but it is quite cool because you can integrate things like Google Analytics, so you can see how many people have been looking at your Shiny app and using it. That's something you can look into, and it's fairly easy to implement. You can use the ProfViz package to profile your Shiny app and see like what's taking so long. Because when I first started making Shiny apps, I was using like quite big data sets, and it was taking like a very long time to load. So if you start having those sort of problems, I recommend profiling it and trying to understand what computation is taking all the time. You can also do things like you can cache, which essentially is like for a given set of inputs, you can essentially save the result of a computation and use it later. So for like the same two types of dog, for example, you can like save the results from like Dachshund and, oh, we're actually on the app already. You can like save the results from these two. You can like save the results of this plot if it took ages to generate this plot, which it doesn't, but if it did. And then if a user entered those two again, it would generate much quicker. So you can do that sort of thing. And there's loads of other things you can do to improve the performance as well. So don't be disheartened if your Shiny app takes forever initially, because you can make it better. Just pointing out finally some introductory resources. Obviously the Shiny website is like, it has so much on there already. It's really, really useful. I came across this github.io site from Lisa De Bruin in Glasgow. It's really useful as well, and it goes through like each step in quite a lot of detail about how to build your first app. And this book, Mastering Shiny by Hadley Wickham, is an essential read as well, and that's available online. That is the end of my slides. I'm happy if there are any questions, but I'm aware that we're like at the end of the session. And please don't forget to build your own app and share it with us, me and Chris, because Chris also wants to see the apps.
We just got a thank you, so that's very nice. Thank you very much. There's nothing on Slack, nothing on Twitter again. So, so I think we're okay for the questions.
Perfect.
We'll just double check YouTube, but we haven't had any come in so far. No, there we go. No. Excellent. We've got a couple of thank yous on Slack as well, which is nice.
Great.
So I think that's yeah, I think that's us done.
Perfect. Well, thanks very much for letting me talk about Shiny for 2 hours. That was really fun.
Oh, hang on. Oh yeah, I was like thinking, why is the Q&A started lighting up? Is everyone saying thank you, which is fine. Excellent.